we're going to go ahead and open the our trig and pre-calc tab. And this is all going to run very slow for me now, because I have too many things going, but it is what it is. You should see two tabs right in there. You should see one for first semester and one for second semester. The first semester tab just contains like an archive of everything that my class did during first semester. So it has all the videos and all that stuff from first semester if you need to go back and look at anything for whatever reason. In second semester, you should see under that tab the 4th hour bulletin board. So go ahead and click that. This bulletin board is just kind of a warehouse for like all the quick things get during the course of the semester. So we have the information for me, the syllabus, Zoom stream link is there. And if there was an announcement, they'd also show up there. But what we want to do is we want to actually go to the resources. So go ahead and click that tab. Tab is mostly like a one-time use sort of thing. If we go to the resource, you're going to see the shared OneNote notebook setup or something to that effect. I am ahead of my browser. But it's the last text block there. When you get there, you should see a hyperlink in that text block. So go ahead and click on that, and that should prompt you to open Microsoft Teams. You can either open Teams from your computer or you can open it through the website. Either is going to be fine. It's no big deal. Just FYI, what we're doing today, we only have to do this one time. From here on, after today, it'll be all done inside of OneNote. You don't have to repeat this process again. So you can either open Microsoft Teams manually or you can use the web app. It doesn't really matter. Since I have it already installed on my computer, I'm just going to go ahead and open it on the computer. If for whatever reason you didn't have Microsoft Teams already installed, which you should have, you could open the web app and do it from there. It's fine to do that too. Okay, so let me pull up Teams. So what you'll want to do, up here at the top, you have this navigation bar, and you'll want to pick Class Notebook from that navigation bar at the top. And then once that notebook page loads, there's going to be a second navigation bar underneath that. And one of the options is going to be Open in Browser, and there's a drop down. I have to wait a second for mine to populate here as it's going super slow. So you see how I have this second navigation bar that's come in here. The piece that we're looking for is the Open in Browser option. And you want to select Open in Desktop App. And that'll open OneNote for you right away. You'll probably get prompted with a dialog box will pop up saying that it's going to do something, and make sure you trust whatever's doing this. Go ahead and accept that dialog box if it comes up. Mine doesn't, because I've already done this to set up my shared notebook already. Now, ideally, if you haven't done this before, it's going to immediately open up the 4th hour honors pre-calc notebook. And if yours already says 4th hour honors pre-calc notebook right there, you're done. You can ignore whatever I'm going to say going forward. If yours doesn't say that right there, we have a little bit of extra step to do. So if yours doesn't say 4th hour honors pre-calc notebook, go ahead and click that drop down. And you're going to pick Open Other Notebooks here at the bottom. And then if you move to the middle part here, you should see on this list of notebooks the fourth hour honors pre-calc notebook as an option to pick. If you just click it, it'll then open up that notebook for you. So I think if you had this class last semester in the same hour, that might have been an issue for you. So if you had fourth hour Trigon pre-calc last year with me, where we tried to do this, you might have had to go in and manually open the notebook. Okay. Okay. Is anybody having issues that needs a little bit of help here before we get moving? Mia?
Mine's like, I clicked the document. Are you gonna come up?
Yep, okay. It sounds like you're not really sure how to describe it. It's probably easier just I see. So close this and do the drop down here. And open up the notebooks. And you should see it's
like for the first 9 course questions. How much you goes 1 through 14 is not that much. Number one's like
Number 1's 1 through J. Or like 8. I don't like this. Oh, I don't like
That's like the whole alphabet.
negative. Oh, this honestly, probably. I
do you use Google Hangouts?
Oh.
What?
Maybe I need to update.
I'll put a 6.
You're definitely my I'll just say.
No, I know I can get in.
How do you use it? Math?
I feel like I'm
just need to sync there to do it. You're welcome. Okay. Anybody else? Issues? Okay. So a little tutorial on OneNote. So inside of your shared OneNote file, you're going to see like 3 tabs right at the top. One that says collaboration, content library, and then one that says your name. Everybody see that? So the collaboration space we will not really use, so you can ignore that. Under the content library, this is the place where I'm going to load in documents that I want to share with you guys digitally. So if you look at our content library, you'll see there's a whole bunch of things in here already for you. Now you can't edit anything in the content library, only I can do that. But you can copy and paste things from the content library into your section, the section under your name, and then edit them there. So for example, this piece that says first day is something we're going to do right now together. So you're going to copy this page. So you'll just right click on where it says first day over there on the right, and then pick copy. And then you'll back up using that little arrow next to the welcome part. And then you'll pick your name. I'm going to click on teacher only because that's my space. And then over here on the right, you can right click and click paste, and it'll dump that first day page in there. And then you can fill that out. So if you haven't done that yet, take a moment and put that in there for me. We're just doing some soft skill maintenance here to make sure that we can do things in OneNote, because some of you guys that were in my class last semester probably feel very comfortable here. Some of you that haven't used this as a class tool may not feel as comfortable, so just making sure that we can do some of these things. Okay, Any copying that over and then filling things out should have taken you just a minute to fill things out, right? You're just signing your name and writing a number. Yep. Okay. You'll also see in the content library, I have the wrong syllabus in here. That's embarrassing. Yeah, you're just signature signing it. It doesn't really matter. Tess, it doesn't really. It's just something to do. You know, checks to see that you have a stylus. It checks to see that you did it. It's mostly just that.
That is a really fancy signature, and I love it.
I have no idea. No, we were not playing with Avery.
We're in the right spot here.
Come on.
A massive, like, 60
I don't know. Thank you for that.
I'm just like, dude, who is this thing? I've never seen on.
Who's made it 9 to all of a sudden
I don't know, maybe.
Oh my gosh.
Maybe
All right. So, excuse me. Back to, so the also in the content library syllabus, this is also on PowerSchool and probably some other places that. So things that you need to have a graphing calculator. You need to have a stylus that works. Just doing some of the greatest hits. Grades for this course, 50% comes from tests, 15 from homework quiz, 10 from homework, 25 from exam. The grade breakdown, extra help. Mornings and community time are best for me. Yada, yada, yada. Homework. Typically, I am going to check the homework just once per week. So we're going to have one due date for the homework per week. So any homework that gets assigned during the course of that week is going to just be checked all on that one day. That one day is Sunday midnight. And you're going to put all your homework into your shared OneNote. And I'm going to check it all from the shared OneNote. We'll talk more about how to do that a little bit later. But hopefully that makes life a little bit easier for you guys to manage your time in that there's only one homework check a week. So if you need to rearrange your schedule, you can do that a little bit. We'll also have homework quizzes. The homework quizzes are unannounced. They're short. They're like, 1 to 3 questions. And basically, I'm going to grade them on a 10-point scale based on the quality of your work, not necessarily the correctness. So if I look at what you did and I say, okay, that's generally A work, I'll probably give it a 9, 10. If it's like generally B work, it's like an 8 or a 9. If it's C work, it'd be like a 7 or 8. And I'm just going to be looking at the quality of your work, not necessarily the right and wrongness of it, because if there's so few questions, like if you get something wrong, what the heck does that mean? But if you're basically making, if you're doing basically everything right, but you make a mistake, it's, we'll assign grades that way, which feels a little bit more fair given that it's unannounced and the questions are so few, right? Tests, there'll be typically one test at the conclusion of each chapter. I will assign partial credit based on the quality of your work for most questions. So extended timer for those or whatever. Dress code you guys know about. Computers you guys know about. Academic honesty you guys have talked about before. Absences. In general, if you're absent, you don't need to do anything special on a normal day. So typically I'm going to record the lectures and post them to PowerSchool, or the video to PowerSchool for that. In fact, I'm recording this one right now. If you didn't notice, you might not have. So you can always just go there and watch the video. Sometimes it takes me a minute. This class in particular is going to be the one that maybe it's not up right away because it takes like an hour or whatever for the video to upload, and then I have to post the link and do all that stuff. And sometimes I forget until the next morning or whatever. It happens sometimes. But in general, they'll get there within 24 hours. If you missed a test or whatever, I ask that you have a makeup scheduled within 1 week of your absence. That doesn't mean you're taking the test within 1 week. That just means that you've figured out like a day and a time that you're going to take it within 1 week. Okay, so it could be like 2 Tuesdays from now, I'm going to do it in the testing room. Fine, whatever. That's fine. No big deal. As far as makeups go, testing room and study halls are what you can do. If you missed a homework quiz, you can make those up in community time because they're so short. They're like 10 or 15 minutes. Just let me know and you can come on down to community time and we'll do it and take care of it. Whatever, the stuff that we're going to be covering, we have a lot of things to cover this semester, but that's okay because some of these chapters are fairly short and are not terribly, terribly complicated. But that's a big, long list of topics to worry about. And the first thing for our weekly homework check, for the homework check on Sunday the 10th, is this syllabus sign-in sheet. So it just says that you've read the syllabus and are cool with that, and you've shown it to your parents and or guardian, and they're cool with that. But you do need to do that. So you'll just move that into OneNote. You can either do it in OneNote, like sign it with the stylus, or you can print it out and sign it with a pencil, and then take a picture of it and put it back into OneNote. Either is fine with me. But that's Sunday's homework check. We need to do that. And if you looked at the PowerSchool calendar, you'll see that's already on the calendar as an assignment. So, all right. Any questions about any of that stuff? Okay. I have one more thing to do before we start talking about trigonometry and precalculus. For this course, today called Dropbox Practice or something like that. My computer's being so terribly slow. But do you guys see that? So if you click on that, you'll notice there's a PDF attached to it, right? You guys see that? Oh, it's blank. Interesting. fix that then. I must have forgot to do that. Well, that's okay. I'm glad you guys spoke up and said something. Not the first time I've made a mistake. What's that?
At least in this class, Alex won't be blank writing anything. It's just any small mistake, it was Alex.
Oh, that's good to know. I've already got a scapegoat then. I'll do that later when things have slowed down. I don't want to wait for it. All right, so I lied. We'll do that Dropbox practice later because, quite frankly, my internet is crawling along at the speed of a turtle, and I don't want to wait for it. I'm too impatient today. So we'll go ahead and start talking about trigonometry and precalculus. So the lessons that I'm using as the basis for my notes are here in the content library called Lessons for Chapter 7. My notes that I'm writing down right now will also be in the content library titled with the date. So if you want to take paper and pencil notes or OneNote notes, you're welcome to do that. If you want to just sit and watch because you'll have my notes in the content library, you're welcome to do that. Whatever works best for you, I'm going to trust that you are responsible, adultish people that can make that decision that works best for you. Because quite frankly, like I've been a student and I've had classes where I needed to take notes, and there were classes where I didn't need to take notes, and there were classes that were moving so fast that it was counterproductive for me to try to take notes. It was better off just sitting and trying to pay attention and listen than trying to keep up with the notes, because it just became a mess and I was not listening to what was going on. I was too busy trying to write things down. It just was not going well. So I'm going to trust that you guys, or give you the freedom to kind of figure out what's going to work best for you in this kind of a context, and you can do whatever you like, okay? I will never ask to look at your notes. So whatever you're putting in there is for you. Yeah. So we're going to start the semester off with Chapter 7, which is another trigonometry topic. This was something that often gets or fits into first semester, but we didn't quite make it in it there this year this year because of everything going on or whatever. But it's a short chapter. It's fairly straightforward. So we're going to just hustle straight through this. I think we can probably do the chapter in 2 lessons and get out of town and on to next things. Okay? All right. Yes, please. In general, if you can't see the board for whatever reason, in particular if the light is an issue, you do not have to ask. Just get up and turn off the light. Will not be offended at all. It's more important that you can see see the board than anything else. Elizabeth.
You're following the Chapter 7 lesson with the stuff, right?
Yes. Yeah, that's what I'm using as the basis for my notes. So there'll be some things that I might do a little differently or a little bit whatever, but we're doing the same topics. Generally, I'll use the same examples or whatever. So if you remember back in like Chapter 2, we reviewed right triangle trigonometry, right? Where we basically just use Sohcahtoa to solve a triangle. You guys remember doing that? Same thing you did in geometry a long time ago. The drawback to Sohcahtoa is that you have to have a right triangle. What we're going to do here in this chapter is kind of extend those definitions so that we can use sine, cosine, and tangent to solve for triangles that are not right triangles. So to do that, we're going to start by deriving the law of sines. So what I'm going to do right now is like a derivation. I'm going to show you where this formula comes from. This is not something I would ever expect you to repeat or be able to do again on a test. I'm just going to show you how we arrived at this formula so that you have a better understanding of kind of where the formula is coming from. So let's just say we have some generic triangle that's not a right triangle. Notice that I didn't put a right triangle angle or right angle marker in any of the corners, so we know it's not a right triangle. This does continue to work on right triangles, but it just turns into like your Sohcahtoa definition, which is not terribly interesting. So I've named the vertices of this triangle A, B, and C. The convention when naming the sides of a triangle are to use the lowercase letter of the angle name opposite that side. So for example, this side is across from the angle A. So I would refer to this as side A. Similarly, this side is across from angle C. So I'd refer to this side as side C. And that leaves, obviously, then this side is got to be B. Is everybody okay with that convention that we use to name the sides of our triangle? Fairly straightforward, but it's really important that you're able to do that because that's the way we're going to be filling in the formulas using those same letters. So got to make sure you're using the right side lengths. Okay, so this is not a right triangle. What do I do? Well, I'm going to draw in an altitude for one of the side, or for one side, or for one of these angles. It doesn't matter really which one you use. I'm going to use angle C because of the way I drew my triangle. It's easier to draw that one. And I made two now right triangles. Everybody agree with that? Okay. I'm going to refer to this altitude here as H. And now I can use Sohcahtoa because I have two right triangles. And there's two things that I can say. I can say sine of angle A is equal to opposite over hypotenuse. And I can say sine of angle B is equal to opposite over hypotenuse. Everybody okay there? Nothing tricky going on. Notice that each of these contain the one variable that is the same. They both contain the variable h. So basically what this is I have a system of two equations, and I'm going to use substitution to solve this system to get rid of the h. Since the h is not really part of solving for a triangle, right? It's not one of the side lengths or angle measures. So I'm just going to multiply both sides of the first equation by b, and then multiply both sides of the second equation by a. And now since both equations are equal to h, I can set them equal to each other. And the convention now would be to divide both sides by AB. Again, it's okay to do that because A and B are side lengths of a triangle. So I know they are non-zero. In general, you don't want to divide both sides of an equation by a variable, but since A and B are side lengths of a right triangle, I know that they're non-zero. And we have this relationship. Sine of angle A over A is equal to sine of angle B over side B. And we could do that again by drawing a different altitude, and we could get that angle B is equal, or angle B, I'm sorry, sine of angle B is equal, sine of angle B over B is equal to sine of angle C over C, which completes our law of sines. So this is our law of sines here. So that's our formula that we're going to use. Now you can use any two parts of this formula that you need. So you could use this part and this part and set them equal to each other. Or you could use like this part and this part. You know, you can take any two fractions and set them equal to each other. Everybody's good with that? That you don't have to be using all three. You can just use two. Okay, so let's do an example. Let's say we have the triangle ABC, where angle A is 32 degrees, angle B is 73 degrees, and side C is 13 inches. So what I would do to start is just by drawing a picture. And obviously this picture is not to scale. Probably makes more sense to do that. So I'm just going to draw my picture and fill in my information. Everybody feel okay with what I've done there? Nothing shocking? Now, right away, one piece of information is really easy to get. What is that? Angle C. Why is angle C so easy? Yeah, we know that all the angles in a triangle have to add up to be 180. So if I do 180 minus the other two, we get the value for angle C. Cool. That was not hard. Now, to find either the side lengths for A or B, I'm going to have to use the law of sines, right? Because there's no other way to get those side lengths. I can't use the Pythagorean theorem because we don't have a right triangle. I can't use Sohcahtoa because we don't have a right triangle. Have to use the law of sines. So I noticed that the only piece of information I have where I know the angle and the opposite side is here for side C and angle C. So I can take those and set them equal to, say, side or angle A over side A. And now I can solve for A, right? So typically when I have something like this, where I have one fraction equal to the other, we call that thing a proportion. And kind of the gold standard in solving is to cross multiply and divide. So when I cross multiply, I get A times sine 75 and 13 times sine 32. If I divide both sides by sine 75, I get this fraction. And if I type that now into my calculator, making sure that I'm in what mode? Degree mode. How did I know I needed to be in degree mode? Because the angles that were given to me were in degrees, exactly right. So there's my answer for side A. Everybody's okay with that? Nothing tricky, right? We just used the formula. How am I going to solve for side B? Can I use the Pythagorean theorem because I know two side lengths? No! Why not? Not a right triangle. And you're like, why do you keep saying this? Like everybody knows it's not a right triangle. People forget. Every year somebody forgets and makes a big mess out of an assignment like this because they start using the Pythagorean theorem all over the place. And I just want to drill that in and remind us so that I can't feel bad. Like, did I not say that enough? I'm going to definitely say it enough. All right, so we still need to find side B, so we're going to do the same thing. I'm going to do sine of angle C over side C equals sine of angle B over side B. And when I cross multiply and divide, I get sine, or 13 times sine 32 over sine 73. And when I, 13 sine 73 over sine 75, oopsie-daisy. And that comes out to be 12.871. My apologies. Anthony. Of course. One last thing I should mention here, that we have a nice little quick not exactly a check, but like a confirmation to make sure that we didn't make any horrendous mistake. If you remember from geometry, we know that the side lengths of a triangle should be proportional to their angle measures. So since I know that angle A is less than angle B, which is less than angle C, I know that side A should be less than B, which is less than C, which is exactly what we notice, where side A is 7.1-ish, side B is 12.7 or 12.8-ish, and side C is 13. Everybody's okay with that? Again, you don't need to do that. That's just like a little check for yourself at the end to make sure you didn't do something horrific. But that theorem from geometry is quite helpful to remember. Let's do another. So we're going to solve the triangle ABC, where A is 108. Oops. Angle A is 108. Side A is 15, and side B is 10. So again, we'd start by drawing a right triangle. Or I'm sorry, not drawing a right triangle, drawing a triangle and labeling it. Everybody good with how I labeled that? Okay, we have three things to find. We need to find angle B, angle C, and then side C. Nothing is for free right away though, right? We have to go straight to the law of sines. And what quantity am I going to have to use? Well, the only one where I know the side and the angle opposite it is for angle A. So I know I'm going to have to use sine 108 over 15. And the other piece of information I know is side B. So I know I'm going to have to be finding angle B for that one. Everybody okay there? Okay. So if I cross multiply and divide, I get sine B is equal to 10 times sine 108 over 15. And then to find the angle B, I'm going to have to do sine inverse of that. So that's about 39.349 degrees. Now that I have that, I can find angle C quite easily. And now that I know angle C, I can find side C. By doing the law of sines again. Everybody feel okay on doing this? This should be relatively straightforward, right? Not anything too tricky right here, because all we're doing is using a formula to do these. Now there is something that is quite tricky involving the law of sines, and that's called the ambiguous case. So remember back to geometry. I know that's asking a lot. Do you guys remember the congruence theorems? These are usually like 3-letter combinations. Do you remember those any one of those congruence theorems? Side angle side. Side side side. That angle was a similarity, not a congruence theorem. That's okay, but that's very similar.
Was there an SSA?
There is not an SSA. There is an ASA and an AAA or AAS, but there is no SSA. Why is there not a side congruence theorem?
I remember seeing a whole thing about it, but I don't remember a single fact.
Okay, so the reason there's no side angle congruence theorem is that it's possible to have two distinctly different triangles that have that same information. So, for example, let's say that we have a triangle that looks like this. So notice that for triangle ACD, we have SSA. And for triangle CDB, we have SSA. But those two triangles are definitely not congruent, right? Everybody's okay with that? Now, this can happen in doing a law of sines problem. We saw from the previous example that it was possible for me to give you a piece of information where I give you two side lengths and an angle, and I ask you to do the law of sines on it, like what I just did a moment ago, right? In that case, there was only one answer. In some cases, there can be two answers. Two different triangles might be possible. And in some cases, there might be no answer where no triangle is possible. So we need to sort that out. So if the given angle is obtuse, and we have the following three situations can happen. So if the side opposite the given angle is the largest side, we just get one triangle. If you go back to the previous answer or example, you saw that was the case, right? Where we had 15 was the side opposite our given angle, and the other side was 10. If that's not the case, then no triangle is going to be possible. Why would that why would it be impossible for that not to be the case? So if the largest angle is obtuse, the side opposite must be the hypotenuse. Can the hypotenuse be smaller or equal to any other side of the triangle? With an obtuse angle? No, that's impossible. That's why you're getting no other triangles if it's in the other situation. Does that feel okay? Okay. I don't know why I broke this. Oh my gosh. I don't know why I broke this down into two separate cases. These two could really be combined all into the same thing, but all right. So the same idea if we have a right triangle, right? If the given angle is a right angle, side opposite has to be the biggest because the right angle the side opposite has to be the hypotenuse. So if that's not the biggest, no triangle is possible. And if it is the biggest, only one triangle can exist. The place where we have to be careful is if the biggest triangle is acute, or if the given angle is acute. So the one situation that we have to be very careful about is where the given angle is acute and the side opposite that given angle is smaller than the other given side. That's the case. Then we have, that is the situation that we call the ambiguous case, because we don't know exactly what's going to happen right from the get-go. Okay, so let's do an example of how we do this, okay? Okay. So let's say we have this situation. So we know angle P is acute. Should have probably written that in red, huh? Since I'm answering the question. See that side P is less than side Q. This is the ambiguous case. So the first thing we need to do is determine whether we're looking for 1, 2, or 0, 1, or 2 triangles. To do that, we're going to use the law of sines. I'm going to have sine 56 over 16 equal to sine of Q over 19. So I'll cross multiply and divide. And I'm going to stop here. Rather than doing the sine inverse, I want to see what this number, 19 times sine 56 over 16, actually is. So if that number, when I do the law of sines, before I take the sine inverse, if that number is less than 1, I get 2 triangles. If that number is equal to exactly 1, I get 1 triangle. And if that number is bigger than 1, I get 0 triangles. So that's important. You'll want to make sure that you remember that. So in this case, we have 2 triangles. So far, so good? Okay. So triangle 1, I'm going to write its measurements down over here. And triangle 2, I'm going to write the measurements down over here. In both these triangles, the given information still holds. So I still have all of that. And the first thing we're finding is this angle Q, which will be different in each of these 2 triangles. So I'm going to call this Q1, and this one I'm going to call Q2, just so we don't get confused what angle Q I'm talking about. Is everybody okay with that? So Q1, I'm just going to get by doing the sine inverse of that 0.984 that we had from before. And our angle Q2 is just going to be the complement of that. Or I'm sorry, the supplement of that. So I'm just going to do 180 minus that answer. Always do this. Oops, that's a 7. Everybody's so far so good? Okay. I have 2, so I can now find the third angle. We'll call this other angle R, so QRS, or PQR, excuse me. So that I can just do 180 minus 56 minus 79.893. So R1 is 44.107. And similarly, angle R2 is going to be 180 minus 56 minus 100.107. And that's 23.893. So far, so good. And then the last thing we have to do is find side R1 and side R2. So to find side R1, I'm going to just use the law of sines again. So sine 56 over 19. 16, excuse me. Equals sine of R1, so 79,893 over R. Oh my goodness, look what I did, bunch of dummies. It was my mistake. That's not R1. That was Q1. That's what I should have put there. Jeepers creepers. You ever make a mistake? Happened to me. Oops. Almost did it again. And again, here I'm just shortcutting around having to write everything down because the only difference is I'm putting R2 in for where R1 was. So rather than writing the whole stuff out, I just took the work from the other problem and put in the other value for my angle R. Everybody's okay with me shortcutting through that? I don't want to confuse anybody, so I want to make mention that I did that. So there are my two different sets of measurements for my two different triangles, right? Really, the only tricky part is that first evaluation to try to figure out whether you're having 0, 1, or 2 triangles. And if you get that right, the rest of it should be fairly straightforward. You just doubles your work if you have 2 triangles. Yes, of course. Sarah, right?
Yeah.
Just practicing names. So this feels like a good place to stop to me. You guys feel okay with that? Okay. So just as a quick little recap here, if we had, oh, you know what? Let's just forget it. We'll do it at the end after we've done law of cosines. So the first assignment here is going to be 1 through 14. So when I say 1 through 14, I'm talking about from the problem sheet in the content library. Problems 1 through 14. I want to point out to you on 5 through 10, you don't need to solve those triangles. It's just asking whether 0, 1, or 2 triangles is possible. So like, don't do all the work to solve them. Just figure out how many triangles there are and then stop. Right? You remember in the notes when we did that? So all you have to do is this part. You don't have to do all that mumbo jumbo afterwards, right? Everybody's okay there? Okay. We'll probably finish up chapter 7 next time. I know that feels fast, but should be a fairly straightforward chapter. This is easily the hardest thing we did all in chapter 7 is this ambiguous case piece. So it shouldn't be too bad after that. We have to talk about law of cosines, talk about when to use which law, and then the area formula for non-right triangles. And we're done with this chapter. So it's basically just doing 3 formulas. Should be a nice easy start to the year. Get everybody off to a good start. Wahoo!